All right, here are the notes for today. If you don't have your math book out, you need to go and grab that as well as a pencil, and you'll need a calculator today. Go ahead and open your books to page 103 and write these problems down. So on page 103, we're not going to do the problems in the warm-up that it tells us to do. Go ahead and write these new ones down. And when you have them written down, unpause the video and we'll get started. Alright, these are just to help us review our division facts. So hopefully we can do these without a calculator. If we cannot do them without a calculator, we should start practicing our division again, because that's going to be really important here, this unit. This first one is 6 divided by 2, which is 3. 6 divided by 2 is 3. The next one is 3 divided by 2. That one might be a little more challenging to do without a calculator, but still hopefully we were able to do it without if we really needed to. And 3 divided by 2 is 1.5. The next one is 15 divided by 5, which is 3. Next one is 12 divided by 4, which is also 3. And the last one is 15 divided by 2. Might be a little harder to do without a calculator, but again, hopefully you were able to do that if you needed to. And that comes out to 7.5. Okay, just trying to refresh our memory with some of this division. We're going to get into some ratios kind of things. So, need to get in the practice of division and getting comfortable with those division facts. Our goal for today is I can find the scale factor of two shapes given their side length. So talking about scale factor here today. And you need to listen to this video. So this is for my friends that are listening to music or just going to skip through this video. This is a video you need to listen to. Some of the stuff is not going to be in your book. So if you see your neighbor not listening to the video, give them a little nudge. Because they'll fall behind pretty quick. So we need to be listening to this video. I know I'm not there, but I'll be able to tell tomorrow who did and who did not listen to the video based on what we know when I get back. Okay, first, what is a scaled copy and what is scale factor? And our goal, we said we were going to learn, be able to find the scale factor of two shapes. So let's first talk about what is a scale factor and a scaled copy. So a scaled copy of a figure is a figure that has a common scale factor to get from one to the next. For example, if one side length in a shape is 3 times the size of the original, then all the sides would need to be 3 times the size of original. So all the sides need to have the same relationship with respect. The corresponding sides need to be have the same relationship to get from one to the other. The scale factor in this situation would be 3. So for example, if I had a triangle here, I had a little guy here and a big guy here, and I knew that these were scaled copies because I told you, and I'm going to say the scale factor is 3. Okay, if this side was 2 and this side was 3 and this side was 4, for example, to get to the big guy, to use my scale factor, I would just multiply each side by 3. So 2 times 3 is 6, so this side would be 6. 3 times 3 is 9, so this side would be 9. And 4 times 3 is 12, so this side here would be 12. Those are scaled copies of each other. The scale factor there is 3 because I took each side length multiplied by 3 to get to that, to get to my new triangle there. So the scale factor is just the ratio of any two corresponding side lengths and two similar geometric figure. Similar is going to be a new word here. We'll talk about that a little bit later this unit, but know that if we have a scale factor, that means that those shapes are similar. So let's practice with scale factor a little bit. I have a couple shapes here, and we're just going to see if we can figure out what the scale factor is. So in this first one, I have two triangles. Okay, and first let's find the corresponding sides. So the sides that match up in the little and big ones. So this side is corresponding with this side here. This bottom side is corresponding with this one here. And this diagonal is corresponding with that one there. So those are our corresponding sides. Those are the sides we're looking at. So in this first one, we need to figure out how did they get from 6 to 12. So kind of what you got to do is you have to figure out 6 times what equals 12. And to figure that out, if you don't know that right away, okay, some of us probably know what that is right away, you're going to take your either ending divided by your beginning. So I'm going to do 12 divided by 6. What is 12 divided by 6? Well, 12 divided by 6 is 3. Not 3. Oh my goodness. 12 divided by 6 is 2. So I figure out that 6 times 2 equals 12. So my scale factor should be 2. Now, a good way to check this is that all the side lengths should have the same scale factor, okay? So if my shapes are similar, if they are scaled copies, okay, all of them should be the same. So if I look at my yellow sides there, I'm going to go 8 times 2, because that's my scale factor, is 8 times 2, 16. Yeah, 8 times 2 is 16, so that does work out. And I'll check again with my green side. 10 times 2, does that equal 20? And it does. So my scale factor is 2. In my small triangle here that I started with, I took each side and I doubled the length of each side to get to my bigger triangle. So my scale factor is 2. Okay. Now we have this next picture. We're going from this big one to the small one. So we're going to do the same sort of thing, and it might look a little funny, but same thing. I'm going to first start off with corresponding sides. So those two sides are corresponding. They're the same side in the shapes. Those green sides and my yellow side are the same. Not the same, but they're corresponding, right? So now, okay, I need to figure out how I went from this big one to the small one. So I have to figure out 4 times what equals 2. And this might be one where you go, you can't figure it out right away. Like maybe we knew that this was 2 right away without doing this division piece, okay? But in this one, it might be a little more challenging to see. So we need to do our division. So we need to go with what we ended with, which in this red side here was 2, divided by, and what we started with was 4. Let me write that so I have more space. 2 divided by 4. And when I get 2 divided by 4, I get half, or 0.5. And hopefully if you type that into your calculator, you got the same thing. Okay, so 4 times 0.5 equals 2. Go ahead and type that into your calculator and just make sure that this is what you get. And that should be true. So again, we need to make sure this checks out for all of our sides. So our next one is going to be 6 times 0.5. And go ahead and type this into your calculator. Does that equal 3? Did I get to where I ended? And if you typed it incorrectly, it is true. And lastly, our green side, 2 times 0.5. Type that in and we should get 1. Our answer to be 1, because 1 is what we ended with there. And since those are all true, these are scaled factors, or scaled copies of each other, and our scale factor is 0.5. I multiplied each side length in my first triangle by 0.5 to get to my second triangle. Okay? So my scale factor is 0.5. So those are a little bit of some more basic examples. 0.5 isn't a super common number, but it's not as messy as maybe we could get. 2 is a good number, just doubled some easy numbers. You might just see in this second example here, it cut in half. 4 divided by 2 is 2. 6 divided by 2 is 3, and 2 divided by 2 is 1. If you can see it cut in half, that's a good thing to see too. But notice that scale factor is half because each side length cut is cut in half. So now this one, last one of us finding the scale factor, is in these triangles. So we went from this triangle to this bigger triangle. Okay, so we need to do the same thing. We need to figure out first our corresponding sides. So this red one matches with this red one. This blue one matches with this blue one. And this green one matches with this green one. Okay? And now we need to figure out what the scale factor is. So in order to do that, I need to figure out 8 times what equals 12. And this again is one that we might not be able to see right away what the scale factor is here. So we're going to have to do another division. So we're going to do 12 divided by 8. And I want you to go ahead, type that in, maybe make a prediction and see if you can guess what it is before you type it in. But do 12 divided by 8, and hopefully you get that to be 1.5. So 8 times 1.5 equals 12. So I'm assuming my scale factor is 1.5. But again, to check our answer, we can go back and check it with all the sides. Because if 1.5 is my scale factor for one side, it's going to be my scale factor for each side. Okay, so if I check my blue sides, 6 times 1.5, does that equal 9? Go ahead and type that in. 6 times 1.5, does that equal 9? And it sure does. And so now we'll check our green side. 10 times 1.5, does that equal 15? Go ahead and type that in. 10 times 1.5, and you should get, yep, that does give us 15. Okay, if one of them was wrong, okay, if one of them didn't give us what we know our second triangle is, okay, then we know that we did something wrong, and maybe we need to recheck our scale factor. Okay, if 1.5 doesn't give us what we need to get to in the end. Good way to check your answer there. Okay, so that's kind of how we find scale factor. Hopefully that's a review for us a little bit. Finding scale factor, ratios. I know you did ratios a lot, 7th and 6th grade, so just bringing that back a little bit, but just a little overview. In order for shapes to be scaled copies of each other, they should have a scale factor, okay? And scale factor is the number that we just found in all of those, okay? Maybe I didn't write it down here, so maybe I should make that clear. The scale factor here was 1.5, okay? Scale factor here is 1.5. All right. So, for example, if one side of a triangle is cut in half, in order for them to be scaled copies, all sides should be cut in half, okay? So, because to get from 4 to 2, we divided by 2, okay? 2 divided by 2 is 1, okay? And 6 divided by 2 is 3, okay? They're scale copies because we did the same thing to each side to get to one to the other. The common scale factor here is 0.5. We cut each side in half to get there, okay? All the sides need to have the same relationship. So now that we did that a little bit, now I'm telling you that these figures are scaled copies of each other. So now we need to find the missing side length, okay? So I'm going from this little one to the big one, okay? And I need to figure out what this small side is, okay? And I know to get from this side to this side, okay, 2 times what equals 4. And hopefully this one's an easy one for us. Hopefully we know pretty quick that 2 times 2 equals 4, which means our scale factor here is 2. So now I know that this question mark, that was a bad question mark, but the question mark times 2 equals 4, because that's my missing side length here. These two are corresponding, okay? So my question mark, whatever this number is here, multiplied by 2, my scale factor has to equal 4, which was what my end side length was there. And what number times 2 equals 4? Hopefully, again, that's an easy one for us. 2. 2 times 2 equals 4. So my question mark here equals 2. This was kind of an easy one because we had a square going on. But yeah, we figured out what our scale factor is, and we used it to find our missing side length. So let's practice that again. Okay, these are scaled copies of each other. Find the missing side length. This still isn't in your book, okay? So don't freak out. We'll get to our book in a little bit here, okay? This side and this side are corresponding, and this side down here and this side down here are corresponding. We need to figure out what that bottom side is on the bigger rectangle. So we need to figure out what our scale factor is. So we have to figure out 4 times what equals 8, right? Because this was what 4 was what my original was, and I got to 8. And again, hopefully this is an easy one for us. We don't have to do the division, but if we didn't know, remember, you could just do 8 divided by 4 to figure out our scale factor is 2. Okay, our scale factor is 2. To get from here to here, I multiplied by 2. So then to get from here to here, I'm going to have to multiply by 2. So 1.5 times 2, that equals 3. Okay. My scale factor was 2, and I used my scale factor here to find my missing side length. All right, last one before we get into the book, okay? I have my corresponding sides, 10 and 30, and this corresponding side goes to this one, okay? To get from 10 to 30, I have to figure out 10 times what equals 30. And hopefully, again, that's an easy one. If not, you can do 30 divided by 10, which is 3. Okay, so my scale factor here is 3. So 10 times 3 equals 30. So I need to do 15 times 3 to get my missing side, which gives us 45. All right. So that's our scale factor stuff. Again, I want to go back to this slide here. Okay. If one side of a triangle is cut in half, in order for it to be a scaled copy, all the sides have to be cut in half. That's going to help us with what we're doing in our book here. So again, look in your books, page 103. Okay. We have rectangles, this big rectangle here. It says rectangles were made by cutting an 8.5 inch by 11 inch piece of paper in half and half again, and so on, as illustrated in the picture. So we have a big sheet of paper, they cut in half. Those dotted lines are the lines they folded on, okay, and that's the picture that we have here. So number 1 says, some of the rectangles are scaled copies of each other. Scaled copies of the full sheet of paper, rectangle A. So rectangle A might be hard to see, but that's this whole thing. Whole thing. So that green one is rectangle A. And maybe I'll trace A and green so we know that A is rectangle, is the green rectangle there, that big one. Okay, the short side is 8.5 inches, this side up here, and the long side is 11 inches. And remember, in order for something to be a scaled copy, you need to do the same thing to both sides. Okay, so we need to figure out which ones are scaled copies of A. So let's first look at B. Is B a scaled copy of A? Well, in B, okay, B is this red rectangle here. Okay, in B, it looks like I cut this long side in half, right? So this long side is 5.5. But now my short side of the original is still 8.5. Okay, so I cut one side in half, but I kept one side the same. So is that a scaled copy? No, because in order for a scaled copy, I would have had to cut both sides in half. So this is not a scaled copy. B is not a scaled copy, so we're not going to write it in our table here. So now let's go to C, which is this guy down here, the blue one. Okay, and we can see that when we folded it, we cut the short side in half. So what is 8.5 divided by 2? Remember, 8.5 can also be written by 8.5. So what is 8.5 divided by 2? Go ahead and type that in, and you should get 4.25. So we cut that side by 2. It looks like we cut the long side by 2 also. So this is 5.5. Okay, and C is a scaled copy because I cut both the short side and the long side. I cut them both in half. So they are scaled copies of each other. Okay, so see, my short side is now 4.25 we got. And my long side is now 5.5. Okay. Now we'll move on to D. It's in yellow, not the best color, but it'll work. Okay. D again looks like I still have half of my short side. I have the other half that C had, so this is 4.25, half of the short side. Okay, and the long side looks like I only have a fourth, right? I have half of what C had for the long side, so I need to take 5.5 divided by 2 to figure out that that is 2.75. And that is not a scaled copy because I did not do the same thing. The long side is only a fourth, and my short side is cut in half. So I did not do the same thing to both sides of my original. So they're not scaled copies. All right, the last one looks like I have 2 E's. Okay. E looks like on the short side it's a fourth of the original. Okay, so it's 2.125. It looks like it's also a fourth of my long side, which is 2.75. And since each side is a fourth of my original, my green one, which you can't really see anymore, since both sides, my short and my long, are a fourth, okay, that means it is a scaled copy. So E is a scaled copy. My short side is 2.125, and my long side is 2.75. Perfect. So remember, for it to be a scaled copy, both sides have to have the same thing done to it. So I'm going to erase all this jazz. Well, maybe I shouldn't have done that, but it'll be fine. Okay. B was not a scaled copy because it still has the full length. It still has the full length of the short side, but this long side got cut in half. Okay, so since the same thing didn't happen to both sides, it's not a scaled copy. One side, this long side, 11 inches here, got cut in half. Okay, it went from this whole green thing to just the red part. Okay, but this side stayed the same. Stayed the same length. That's why it's not a scaled copy. So now you're going to flip the page over to page 104. Go ahead and flip the page over. We're on page 104. Okay. And now it says some of the rectangles are not scaled copies of the full sheet of paper. Rectangle A. Okay. So now we would need to record those. So the ones that were not were rectangle B and rectangle D. And when we do rectangle B here again, okay, remember if you're looking at rectangle B, the short side is still 8.5 and the long side is 5.5. But now my long side and my short side flip, right? So my short side, the shorter side is actually over here now. So 5.5. My long side is 8.5. 8.5 is bigger than 5.5. All right, and D, it was not a scaled copy. Okay, so for this side here on the top, okay, it's cut in half of B. So D is half of B, so 8.5 divided by 2 is 4.25. And it looks like it's a fourth of 11, which we got was 2.75. So again, my long side and my short side flip. So my short side is 2.75. And my long side is 4.25. All right, there we go. So today, really, we just worked scale copies of each other. Hopefully we understand what it means for a shape to be a scaled copy, okay? But now I want you to look at number 4, okay? And number 4 has this stacked for you, okay? It says they stacked the rectangles that are scaled copies on the full sheet of paper. So this red one shows, rectangle A, rectangle C, and rectangle E, okay? And this blue one shows rectangle B and rectangle, whoa, that was weird. Rectangle B and rectangle D. Okay, so these are the ones that were scaled copies, and the other ones were the ones that weren't scaled copies, okay? And then it says they want you to draw a line from the bottom left corner to the top right corner. Let me do that in a color you can actually see. So yeah, it wants you to draw a line connecting those two. So go ahead and do that. Draw as straight as you can. You might want to use like your ID or something to draw a straight line. I wonder if I can use this ruler to help me. We know I can't draw a straight line. Ooh. Look at that. All right, now I'm going to draw a straight line. Okay. Gosh, that wasn't even that good. Let me try again. There we go. Okay, let's see if I can do it now. Beautiful. Okay, not perfect, but okay. And I want you to do the same thing in the blue triangles. Draw a line from the bottom left to the top right. And then what I want you to notice is that we intersected at every top right corner. Your line should have intersected at every top right corner. Okay? So when we stacked these, if we stacked all of them on top of each other, we could tell which ones are scaled copies because it's just a fun trick. It's like a magic trick. You know I'm all about these magic tricks. They intersect in the top right corner. So we would have been able to tell without even doing the work that we just did which ones are similar by the ones that intersect at that line. And those lines that we draw are going to be important. Okay, so for the rest of class, you need to go on to Schoology, your job, is you're going to go to Schoology and do the 2.1 cool down. This will be going in the grade book. You need to get a 4 out of 4 or a 2 out of 2 or whatever it is. You need to get 100%. Okay, 100% on this cool down. Okay. If you are still listening to this, I want you to send me a message on Schoology to tell me that you are still listening for some extra points on that test that we just took. Don't tell your friends, because I will know if you tell people that to do this, because not everybody should be sending me a message on Schoology. So again, if you are still watching this, you should send me a message on Schoology so I can get you an extra point on the test. Thank you for listening. And get your cool down done. Have a good day.